Okay, here's a short video. What I'm gonna do is we're gonna work on these word problems in class over the next couple days. I'm gonna go over number 2, and then I'm gonna ask that you try number 3 and try to give you some strategies here as well as any makeup work today. And then we'll work through them as we go. So let's look at number 2. So these are in the sinusoidal setup area. So Lamage rode his bike over a piece of gum. Lamage continued riding the bike at a constant rate. At a time of t equals 1.25 seconds, the gum was at a maximum height above the ground, and 1 second later, the gum was at a minimum. If the wheel diameter is 68, find the equation to find the height of the gum at any time. Now, here's the strategy that I would like you to do. Okay, I'm going to draw a line here, and I'm going to mark off that line's not very good, so I'm going to try it again. Okay, like this. And I'm going to mark off some stuff that's given. So what it says is at 1.25, okay, the gum is at its highest point. So I'm going to model that there. Now, if this is gum on a tire, does everybody agree that the minimum would be at 0? So when does that occur? That occurs 1 second later. So this is just some problem-solving strategies. I'm going to call that 2.25, and I'm going to call it right there. Now, what do we know about a sinusoidal function, which could be sine or cosine? I don't know if you can see this yet, but we could model this as a cosine curve, correct? Because it starts high and is going down. I'm not sure if we've given enough background on that, but if you think about this for a second, when is this gum back up at the top? Have we taught you this symmetry? Okay, so it's at its high point here. It's at 0 here. I don't know, can you see at 3.25? It's going to be back up here at the top. Not sure if that makes sense or not. Now, what does this curve look like? It's going to be a cosine curve, like that. Okay? Now, here's the other thing that we worked on so far that I told you was coming. We want to find the midline. The midline does two things in our equation. It gives us our vertical shift and also helps us find our amplitude. Now, how do I find my midline for this problem? Well, the diameter of the wheel is 68 centimeters, okay? So if it's running along the ground, hopefully you can see that this is 68, and this down here would be 0. So where would the midline be? Hopefully I'm not asking for too much math there. The midline would be at 34. Now what does that tell me as we start to build out our formula then? That tells me that the amplitude is either this distance or this distance, which happens to be 34. Okay, so I can say y or h equals, I'm going to put 34 out in front because that's my amplitude. Now, remember we went in the last video, my little b value is going to go out in front here, not inside. I'll tell you what the midline tells me in this case. It also tells me it's been shifted up 34. Now that is going to be common with a problem that runs along a ground or runs along the 0 level. That won't always be the case, but in this case the amplitude is 34 and the midline has been shifted up 34. Now, what's the period? Well, the period is this right here, right? If it takes 1 second to be at the lowest point, it takes another second to go back to the highest point, that makes the period 2. Now, what does that make little b then? Okay, so the period is equal to 2 pi over b, if you remember, or little b, if we do some quick algebra, is equal to this over that. In this case, p is 2. That's going to make little b pi. That's going to go right there. You see how I did that? All right, now, what is the shift? Well, because I chose cosine right here, which I think is the easiest one, where should that start at? That should start at 0, but it didn't, right? How far did it go? I had to shift this to match my curve. Again, I'm doing curve fitting here. To match my new curve, what did I do? I moved right 1.25. So what does that mean in here? X minus 1.25. Okay? And that would be my equation. Now, for the rest of it here then, I mean, that's the biggest one right there. Okay? Now, once I find it, it says find the height of the gum when it gets to the corner and when at t equals, that's what I could have done too here, by the way. Let me change that to t. This is where the t is this time. Okay, when t equals 15.6. So how would I solve this problem then? You would take the 15.6 and you would put it right in there. Okay, now once I put it in there, there's two ways to do it. You can solve them in pieces. I would not. Okay, I would make sure you're in radians, and I would just plug all that in your calculator and get the answer. Okay, now That's the only answer I would like you to get right now. We'll start to talk about the two places where the height is 12. Okay, and that takes a little more development, but just to prep that, where would the height of 12 be? It would be like right here. You see that that occurs at two places, and we'll talk about how to do that in a little while. Okay, now with that little video in mind, what I'd like you to do then is I would like you to try number 3, develop the equation, and try to solve little a. And then hopefully our next class period will catch up on this.